So today we're going to be talking a little bit more about logarithms and exponentials, which you guys did a little bit of an intro to with that worksheet from yesterday. So logarithms and exponentials are inverses of each other, similar to how like multiplication and division are inverses, addition and subtraction are inverses. It's the same sort of relationship there. Today we're going to focus on how to plug these things into our calculators in order to evaluate if we're given an equation. So we'll just get started with an example here. So example 1, the following shows the world population in billions X years after 1949. So when you have an equation like this with a word problem, you first want to figure out what your variables are representing. So here it's telling us X years after 1949, so that means X. So X is just the number of years after 1949. And then our Y value in the equation is just what the equation equals, or what it's telling us, which in this case is the world population in billions. So this right here is what Y equals. Okay, so then that's just giving us some information about the equation. The question now, letter A, what was the world's population in 1965? So it's asking what was the world's population. That means it's asking what does Y equal. That's what we're trying to figure out. And then it's telling us in the year 1965. So we just need to figure out how many years, because it says X is the years after 1949. So we have to figure out that difference there. So to do that, we can just do some subtraction. 1965 minus 1949. So you get X equals 16. So that means now all we have to do is plug in 16 into our equation for X, which is in the exponent there. So when we do this, we'll have Y equals. So I'm going to write it how you would type it into the calculator, or what it would look like in the calculator. So you do 2.569, and then parentheses, 1.017, close the parentheses. Then you'll do the little caret button, then a parentheses. We always want to get into the habit of putting our exponents in parentheses. Some calculators you have to do it, some calculators you don't, but it's a really good habit to get into. And then we type in our X value, which is 16. And then close the parentheses for our exponent and hit enter. So if you could all practice typing that into your calculator. And so when you type that in, you should get 3.36. But we're not exactly done yet, because if you remember, we're trying to find the world's population. The world's population is not 3.36 people. It's not very realistic, and that's because it says our Y, the units of Y right here are in billions. So you have to make sure you add that billion after it. So 3.36 billion people. I want to make sure your answers make sense. Okay, can you guys try letter B? So what will the world's population be? Again, this is asking what will Y equal in the year 2021. So you need to do that. What? What? No, because it says up here, right above our equation, that X is the years after 1949. So you have to count. So that you have to do that subtraction. So you do the same thing with 2021. You have to do 2021 minus 1949. Okay, so go ahead and try letter B. So you should be plugging in an X value of 72. So when you type it in your calculator, you would have the 2.569 parentheses 1.017, close the parentheses, then the caret, and then 72 in parentheses. And what do you get when you type that in? Yeah, Leo?
8.64 million.
8.64 billion, yes. Thank you for the units. Okay.
6.47.
Okay, yeah, so rounding, yep, 8.65. Yep. Don't throw the calculator.
No, I did on my phone.
Well, not any better. All right, so really here you just got to be careful of the exponent part, making sure you're using the caret correctly. Okay, so moving on, we have a number called e, a lowercase letter e. This is similar to the number pi, where we have a symbol to represent a number. E is also an irrational number, meaning it goes on forever and ever and ever, and there's no pattern to it. An irrational number, like pi. And this number e is a common base for many exponential equations. Okay, and so e is approximately equal to 2.718, kind of like how we say pi is like approximately equal to 3.14. It's the same idea, but we do have a button for e in our calculator. So if you hit the, just so you guys can see, if you hit the second button, and then it's a button that says LN, it's the third button from the bottom on the left. You should see a little e with an X in blue there. So, for example 2, we're going to use this e number here. So, medical research indicates that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. And the risk is modeled by the following equation, where R equals 6 times e to the 12.77 x power. So first we want to define the variables. So x is the concentration of alcohol in the blood. And then R is the risk of an accident. Okay, so letter A now is asking, what is the risk of a car accident? So it's asking, what does R equal? What is the risk? That's what we're trying to figure out. If we have a blood alcohol concentration of 0.08, that means X equals 0.08, which is the legal limit. So what we want to do, same as what we did before, we're going to plug in that 0.08 into our equation for X. And here we have a little bit more going on in the exponent, so this is where it's going to be very important that you use your parentheses correctly. So in your calculator, you would have type in 6. And then if you want to do the multiplication sign, that's fine, but you don't have to. It'll be implied multiplication, but 6 times. Then you hit that second LN button to get that E. So again, to get this, it's second LN. And it should pop up with a caret and in parentheses, or it should just put it up in the exponent already. And then you're going to type in what our exponent is, which is 12.77 times, that's multiplication, 0.08, and then you need to close the parentheses of your exponent. Or if your calculator just moves it up, if there's no parentheses, then just hit the right arrow to get out of the exponent. Okay, do you guys have are we all good getting that E typed into our calculator? Okay, so when you type that in, you should get that the risk is 16.67%. Risk of an accident. Okay, we want to make sure that we have our units here when we're doing these word problems. Okay, can you guys try letter B? So again, I'm just giving you two different values for x. So you're going to do one problem where you have x equals 0.01 and one where you have x equals 0.03. Okay, so go ahead and do those. Again, this is really just practice using our calculator and plugging this stuff in. All right, so for a blood alcohol concentration of 0.01, so when x equaled 0.01, you should have got R to equal 6.8%. So that's a risk of an accident. And then for a blood alcohol concentration of 0.03, x equal to 0.03, you should have got 8.8, risk of an accident. Okay. Do you guys have any questions there on how to plug anything into the calculator? So really here, parentheses are your friends. Yeah, Leo?
So we would still use the B, what was 6E, then 12.77, then you would do it.
Yeah, the only thing that's changing is that x value. Yep, so we just did it two separate times. Yep. Good. Any other questions? Question? Maya, do you have a question?
Yeah, what does the E equal?
So that's what we talked about up here, the number E. It represents a number. It's an irrational number like pi. So it goes on forever and ever and ever and ever and ever. So I'm not expecting you to type in an infinity amount of decimals, so the calculator has a button for it. Yep. All right. So that is exponential. So parentheses around the exponent are the main important thing there. We go on to the next page. And now we're going to talk about logarithms, which again is the inverse of an exponential. So logarithms, an inverse of exponentials. Okay, and your calculator has two different logarithm keys. There's one that says the word log, L-O-G. That is also called the common log, or the most because it's the most commonly one used. And if you remember on the worksheet from yesterday, all the logs you were seeing had you had log, and then you had a little number down here called the base. So when we have the common log, we don't have that little number down there written. It's not that we don't have a little base written there. It's just log. And so similar to how like when we have the square root, we don't always have to write the 2 there for square root because it's an implied square root. With the common log, if you just see the word log with no base written, that means it has a base of 10. Always has a base of 10 if no base is written. So that means we're really saying log base 10 of x equals y. So it's implied, it means the same thing. If you see a log with no base written, that means it's base 10. That means it's the log button on your calculator. If you look on your calculator, I think it's on the left side, the 4th button from the bottom. So the LN button below that represents the natural log. Oops. Okay, natural log ln has one and only one base. The log, log log, we can write it with multiple bases, or we can have any number that we want as a base. If we are using the natural log, that ln button, there's only one option for the base, and it's that number that we just learned about, e. So natural log always has a base of e. So that means if we have, I write natural logs with a cursive L. I don't really know why, but that's just my habit. But you don't have to. You can just write normal ln. So if we have natural log of x equals y, that's the same as saying natural log with a base of e, x equals y. That e, that base of e, will be implied for a natural log. There is no other base we can write if we're using a natural log. If we want to use some other base, then we have to use the log log, not the ln natural log. Okay, and again, we have a button for that on our calculator as well on the left side, third button from the bottom, the same button we hit to get our e number. All right, so let's do some examples using these. Example 3, when the outside air temperature is anywhere from 72 degrees Fahrenheit to 96 degrees Fahrenheit, the temperature in an enclosed vehicle, x minutes after exposure, can be modeled using the following equation. F of x equals 11.6 plus 25 natural log of e. So we need to define our variables. So it's telling us that the temperature in an enclosed vehicle can be modeled using that equation. So that means f of x is representing the temperature inside the vehicle. If I could spell vehicle correctly. And it's in degrees Fahrenheit, because that's the temperature that we were given, was in Fahrenheit. And then it's telling us that x is the minutes after exposure. Okay, so that's their number that we're taking the natural log of. So now the question, letter A, what is the temperature in the car? So it's asking us, so what is the temperature? That means we're trying to figure out what does f of x equal after 15 minutes of exposure, which means x equals 15. So to solve for f of x, we're just going to plug in 15 for x into our equation there. So we'll have 11.6 plus 25, and then you use your natural log button, so that's just the ln button. And it should pop up with a parenthesis already for you, and it would be the natural log of 15, and then close your parentheses. Make sure you close the parentheses. Make sure you're hitting the ln button, not the log button. Okay, and so when you do that, you should get that it is 79.3 degrees Fahrenheit. Any questions getting that typed into your calculator? Okay. Then letter B, we want to know after 1.5 hours. Now we have to be careful here because we said that x is minutes after exposure, which means any number we plug into our equation has to be in terms of minutes. But right now the question is asking us in terms of hours. So if I have 1.5 hours, how many minutes is that? 90. So you'd have x equals 90. So in your calculator, you do your 11.6 plus 25. Then hit your ln button. Again, it pops up with a parenthesis already for you. And then you type in 90 and close the parentheses when you're done. And you should get 124.1 degrees Fahrenheit. so it gets pretty hot in the car, so you don't leave your pets in an enclosed car in the summertime. All right, questions there about using the natural log button? Okay, you just gotta remember which one's which. Natural log, LN, N for natural, L for log. Easy way to remember it. Okay, our last one here, example 4. Chemists have defined the acidity of a substance according to the formula pH equals the negative log of H plus, where H plus represents the hydrogen ion concentration measured in moles per liter. Solutions with a pH value of less than 7 are acidic. If it has a pH value greater than 7, it's basic. And if they equal the pH equals 7, it's neutral. So suppose we test apple juice and find that the hydrogen ion concentration is that H plus equals 0.0003. This is what our H plus equals. We want to find the pH value and then determine if it's basic or acidic. Okay, so again, we're given a value for H plus. We just have to plug it into our equation, which is using the common log. So we would type our negative sign, make sure we have our negative there, so negative. And then you hit the log, L-O-G button. And again, it should pop up with a parenthesis already for you. And then you type that hydrogen ion concentration, which is 0.0003. And then close your parentheses and hit enter. And you should get 3.5 is the pH. And then since 3.5 is less than 7, that means this is an acidic solution. All right. You guys have any questions? So again, this lesson really is just getting used to using your calculator to plug in exponentials and logs. The problems give you everything you need to know. All you have to do is plug stuff into the calculator correctly. So please do the homework. Please practice. This should be the easiest part of this unit. So if you can use your calculator, you'll be good. So practice using your calculator. Do you guys have any questions? Okay.